Hi everyone, welcome back to my channel. In today's video, we will learn the technique of solving homogeneous differential equation. Now, before going to the differential equation, first we need to know what is homogeneous function. Now, a function fxy is called homogeneous of degree n if it can be written as fxy can be written as x power n times phi of y by x. That means x power n times a function in y by x. So let us understand it by taking some examples. So first example, we take f of xy is equal to x square plus xy plus y square. Now, is this a homogeneous function? So to determine that, what we do, we take common x square. So we have 1 plus xy by x square plus y square by x square. So it is same as 1 plus y by x plus y by x whole square. So you can write it as x square times phi of y by x, where phi of x is 1 plus x square. So then phi of y by x is nothing but 1 plus y by x by y by x whole square. So fxy is actually x square times phi of y by x. So we called this fxy is homogeneous of degree 2. Now take another example. We take fxy as x plus y by x minus y. Again here what we can do, we take x common. So 1 plus y by x in the denominator, 1 minus y by x. So cancelling both x. So we have 1 plus y by x by 1 minus y by x. So we can write it as some phi prime of y by x. So here also fxy is a homogeneous of degree 0. Now consider another example. F of xy is y times x plus y by x square. So here also we take x common. So 1 plus y by x by x square. So we have basically y by x times 1 plus y by x. So it is clearly it's a function of y by x. So here also it's a homogeneous of degree 0. Now consider some non-examples. So example 4, fxy x square plus y square. Take example 5, fxy is sin xy. Now notice that in the both case we cannot write it as f x times in x power n times some function of y by x. We cannot write in this form. So they are not homogeneous. Okay. So now come back to the differential equation. So let us consider the differential equation of the form dy dx is equal to f of x1. Now we call this ODE as homogeneous equation, homogeneous ODE, if this fxy is a homogeneous function of degree 0. So dy dx is equal to fxy. We call it as homogeneous ODE if this fxy is a homogeneous function of degree 0. Now we will discuss the general scenario of a homogeneous ODE. So we will discuss the technique of solving a general homogeneous equation. So, we are taking dy dx is equal to fxy. Now since this is a homogeneous ODE, so we can write it as a degree 0 homogeneous function. That means x power 0 phi of y by x. X power 0 is nothing but phi of y by x. Now we will make it to a separable ODE by making a transform of variable. We put y is equal to vx. So by differentiating, we get dy dx is equal to v plus x dv dx. So we have v plus x dv dx is equal to phi of y by x. So note that here y by x is nothing but v. So it is equal to phi v. So we have x dv dx equal to phi v minus v. So we have dv. So we get a separable ODE, and we can separate it like dv by phi v minus v is equal to dx by x. So it's a separable ODE, and we know how to solve it. So by integrating both sides, we get c. So this is the general solution of a homogeneous ODE. Now let us take an example to understand the method clearly. So we take one example, which is 2xy dy dx is equal to y square by minus x square. Okay, so let us write it in the general form dy dx. Now note that we can take common x square. So we have one, so we have y square by x square minus 1 in the denominator. Denominator we have 2xy. So we have x times y square minus x square minus 1 by 2y. So we can write it as y square minus by x square minus 1 by 2y by x. So clearly it's a homogeneous equation of degree 0, since we can write it as a function of y by x. So we let y is equal to vx. So we have dy dx is same as v plus x dv dx. So we get v plus x dv dx is equal to, so here note that y by x1 v. So we have v square minus 1 by 2v. Okay, so x dv dx is v square minus 1 by 2v minus v. So v square minus 1 minus 2v square by 2v. So it is same as minus 1 plus v square by 2v. By simplifying, we get this. So we have 2v by 1 plus v square gv is equal to minus dx by x. So by integrating both sides, we get, so note that here the derivative of 1 plus v square is exactly 2v. So it is just ln 1 plus v square. Here ln mod x, and for simplification we take the constant as ln c. So we have, so we can write it as ln c by x. So we get 1 plus v squared is equal to c by x. Now what is v? V is y by x. So now multiplying x square in the both sides, we get x square plus y square equal to cx, which is the general solution of the ODE of the given ODE. So that's how we solve homogeneous differential equation.